Just let me come back because.
Alright, this is section 2.7. We are going to talk about parent functions and transformations. We did cover this in Algebra 1. I want you guys to have a good understanding about transformations because it will make your life a lot easier in the long run, especially when we talk about shifts and when you're graphing things. It makes a lot more sense if you know the general direction of your transformations. So we're going to talk about some different parent functions. And you should have these all on your notes page. Here's our first parent function. It's called the constant function. If I want you to graph something like y equals 5, that's just going to be a horizontal line at 5, isn't it?
Yep.
Right. That's called a constant function when it's just that horizontal line. So let's graph y equals 5 if you would, please. So use your ruler, please. I want you to go up to 5 on your y-axis. We're going to draw in a horizontal line. Please put arrows on the ends. We do want to show that it continues on. 5 could be any number, right? But if it's y equals a number, we know that that's going to be some horizontal graph. Now, what would the domain of any constant function be? All real numbers. Now our range, our y values, they're going to be whatever this y value is. Well, what was y? It was 5. And in our case, it's 5. But it's going to be whatever that a value is. A could be anything. It could be 5, it could be 7, it could be negative 99. It could be anything. The next one is the identity function. This is another linear graph. It's still going to make a line. We're going to graph specifically the line y equals x. Okay? You should be able to graph this. It's in a slope-intercept form, isn't it? You could think of it as plus 0. What's our y-intercept? 0. And our slope is 1. So we would rise 1, run 1. Rise 1, run 1. Take your ruler and draw on the line that goes through these points, please. What is the domain of this function? All real numbers. And the range? It's also all real numbers. So these are the two linear functions. If it's a horizontal line, we call that a constant. If it has an angle to it, its parent function would be the identity. Now, we're going to talk about transformations, meaning shifts in these graphs. We're going to specifically shift the identity, move it up, down, right, left, change its steepness. And we'll talk about that here in a second. Let's graph this parent function. We just did these. This is the absolute value function. What should the shape of this graph look like? A V. So I want you just to draw a little t-chart. We can do this pretty quickly. It shouldn't take too much thinking. 0, 1, negative 1. If I put 0 in for x, I get out 0. If I put 1 in for x, I get out 1. If I put negative 1, I get out 1. I can put in 2. If I get out 2, I get out. If I put in 2, I get out 2. If I put in negative 2, I get out 2. What I'm wanting you guys to be able to do is to come up with these 5 points quickly. Okay? I want you to be able to think, all right, I know if I put 0 in, I get out 0. If I put 1 in, I get out 1. If I put negative 1 in, I also get out 1. I want you to know what these parent functions look like in their basic form. Because we're going to have to plot those basic points and then shift them. The last parent function is called the quadratic function, and we did graph these in Algebra 1. What should the shape of a quadratic function be? Can I say it? Very good, Maddie. It's a parabola. That graph should be a U shape. I don't want you just to rough sketch this thing. I need you to draw a t-chart and actually pick values. I want exact points. So if I put 0 in for x, 0 squared is going to be 0. If I put 1 in for x, 1 squared is going to be 1. What if I put negative 1 in for x? Negative 1 squared is positive 1. Pick some more. Put 2 in, 2 squared is going to be 4. Put negative 2 in, negative 2 squared is positive 4. I'm going to go ahead and put 3, negative 3 in. 3 squared is 9. And what about negative 3 squared? It's also 9. So this is a curve. This is not a straight line. You're going to have to freehand this.
Dang, you suck at that.
Oh, you realize I'm recording my video.
There's mad people apps.
It's not funny to me.
Dang,
Think
chill
about what you're
out.
saying. Okay.
Chill out. I was playing.
But I want you guys to be able to come up with these points immediately. I don't want you to have to think too hard about it. You know 0 squared is 0, 1 squared is 1, negative 1 squared is 1. I want you to be able to plot these points. And 3 points is not enough on this. You're going to need more than that. Okay. So, domain. What is the domain of this function? All real numbers. And the range? Y is greater than or equal to 0. And I think I skipped that on absolute value, didn't I? Unintentionally, let's go back here. What is the domain of this absolute value function? And the range? Y is greater than or equal to 0. If I gave you any of these functions, could you easily identify what shape they're taking? That's what we're doing in the next slide. This first graph, top left, what type of function is that? Absolute value, just write it next to it. The parent function is representing an absolute value function. What about this one next to it, this horizontal line? Constant. Bottom left, what type of function is that representing? Quadratic. It's that parabola shape. And lastly, this one is linear. What type of function is that? Okay, the parent function is identity. This is a linear function, but you're right, the parent function is the identity. We're identifying the parent functions. Alright, you need your book. Hopefully you brought it with you. I want you to open page 112. If you don't have the book, it might be a good idea to send somebody that does. Okay. This table on page 112 is going to help us with transformations, but we have to first understand what in the world this table is telling us, because right now it looks like Japanese, doesn't it? Okay. What I want you to recognize are the translations, the reflections. Those are the two main things we're going to worry about here in Algebra 2, the translations and the reflections. So translations, when I refer to the phrase of translation, that's my shifts. I'm going to take my different functions, whatever they are, and I'm going to be able to shift them right, left, up, or down based on if we're adding or subtracting a number and where we're adding or subtracting. A reflection is going to take our graph and it's going to reflect it across either the y-axis or the x-axis. And that's based on where a negative is. And we kind of know the general sense of that when we talked about absolute value and reflecting down. But those are the main ones that we're going to focus on. Let's go back to our slide. Look at this one with me. It says to describe the translation in y equals the absolute value of x plus 2. We're on the back side of your notes page if you're not already there. So what type of shape is this graph going to be? It's going to be a V. So before we look at the transformations, I I want you to draw in the parent function. Now, remember our parent function is going to be y equals the absolute value of x. I need specific points. I don't want just an estimate. If you still need to do a t-chart, you can do that. If I put 0 in for x, what do I get out?
0.
0. If I put 1 in for x, I get out 1. If I put negative 1 in, I get out 1. What if I put 2 in? I get out 2. If I put 3 in, or negative 2, I get out 2. Positive 2, right? Okay, so before you draw your lines in, I want you to use a dashed line to represent the parent function. You still use your ruler. Yep, still use your ruler. We're just going to make it a dashed line.
Miss Keller,
Yeah?
isn't the equation absolute value of x plus 2?
It is. We're just graphing the parent function right now. We're going to get to that one in just a second. All we're graphing is the parent function. We really haven't graphed the one that's the given to us problem. Now, I fully understand that we could do a t-chart and we could graph this with little trouble, correct? However, I'm wanting you to practice using transformations. So I want to know how this graph is going to shift, at least from its parent function position. So I'm going to take that little t and I'm going to shift it 2 units one direction. Let's figure out which direction we're going to shift it. Go back to this table. The plus 2, was that inside the absolute value bars or outside the absolute value bars? They were outside. Okay. So if you look at your table here, I'm looking at this one right here where it says f of x plus k. F of x means our function. In our case, our function is the absolute value of x, right? We're adding 2. And that's outside the absolute value bars. So what direction does that tell me this is going to shift? It's going to shift up. So let's go back to our graph. It tells us to describe, so we're going to write in words. Shift up. How many units?
2.
2 units. Okay, I need words. I want it in words, and then I want you to actually draw it on your paper. Now to draw it, you know what we're going to do? We're going to take every point on this V and we're literally just going to move them up 2 spaces. Okay? So take all the points that you have plotted. 0, 0, I'm going to move it up 2. 1, 1, I'm going to move it up 2. 2, 2, I'm going to move it up 2. Negative 1, 1, I'm going to move it up 2. Negative 2, 2, I'm going to move it up 2. And then I'm going to draw in my graph. Now this time, please use a solid line. Okay? The solid line is going to represent our answer. The dashed line is simply going to represent our parent function. Like I said, guys, I know we could do a t-chart and we could graph that original problem with no trouble. However, we're wanting to practice using our parent function in our transformations. Okay? All right, let's try another one. This one says describe the translation of y equals the absolute value of. Sorry about that. The absolute value of x plus 3. Then graph the function. Let's start with our parent function. Can you go ahead and place your parent function on this graph? We have a pretty good idea what that's going to look like, don't we? 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. Remember, when we do our parent functions, we're going to use a dashed line. So then let's go back to our table. On this table, where were we adding? It was adding 3, right? That's right. Yeah. Now, do you agree that that plus 3 is inside the function, inside the absolute value bars? So I am looking at which one? The first one. It's inside the function. So this means I'm going to translate my graph h units left. Now that's opposite of what we would think, wouldn't we? We would think plus something, we would go to the right in a positive direction, but it's opposite. We're going to go left 3 units. So let's take all of the points that we plotted on our parent function and let's shift them left 3 spaces. So 0, 0, I'm going to go left. 1, 2, 3. 1, 1, I'm going to go left 3. 1, 2, 3. 2, 2, left 3. 1, 2, 3. Negative 1, 1, left 3. Negative 2, 2, left 3. And this time we'll use our solid line and draw in the sides. So we do need to describe this in words. We said it's going to shift at left 3. Let's do a quadratic function here. So how do I know this is quadratic? What's my clue? Squared. Yeah, 2. So it says to describe the translation of y equals x squared minus 4, then graph the function. Let's begin by graphing our parent function. Now remember our parent function is y equals x squared. Okay, that's our parent function. If you need to do a t-chart to do that, you can if you don't know all the values yet. If you put 0 in for x, what do you get out? 0. If you put 1 in, 1 squared is 1. Negative 1 squared is 1. If I put 2 in, 2 squared is 4. Put negative 2 in, negative 2 squared is also 4. I'm going to go ahead and put 3 and negative 3 in. 3 squared is 9, negative 3 squared is also 9. This is not going to be a V, this is going to be that U shape. We call that a parabola. So please use a dashed curve to draw in this parent function. Okay, so what direction is that minus 4 going to take our graph? Let's go back to our table. That minus 4 is outside the function. Let me back up for a second. If it was inside the function, it would look like this. Do you see the difference? Okay, it would be inside parentheses squared. It's not. It's outside. So what direction is this function going to go? Right here, you agree the bottom one? It's going to translate it k units down. How far down are we going to go? 4 units down. Okay, so shifting down 4 units. Please take all of those points on your parent function and move them down 4 spaces. Do you have a pencil? Once you've shifted them all down 4, please draw in a solid curve. this one, please. It says describe the reflection of y equals negative absolute value of x, then graph the function. Let's start with our parent function. Go ahead and plot those parent function points on your graph. That's what we just did a second ago. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. Let's talk about the direction this is going to be reflected. That negative is what indicates that we're reflecting. Now that is outside of our function. Okay, real quick, I just want to show you what it would look like if it was inside the function. You see the difference? The negative would be inside parentheses squared. Okay? It's not. It's outside. So what direction is this going to reflect? It's going to reflect over the x-axis. So I'm going to take my parabola and I'm literally just going to flip it down. It's here, and it's going to just flip it down. So take all of your points on your parent function, you're literally just going to flip their y value and make them negative. So 0, 0 is going to stay in the same spot. But 1, negative 1 is going to become 1. Excuse me, 1, 1 is going to become 1, negative 1. Taking all the points and reflecting them down across the x-axis. So, real quick, if we had reflected across the y-axis, what would that look like? If I took this half and I reflected it across the y-axis, and this half reflected it across the y-axis, how would this change? It wouldn't. It would be the exact same, wouldn't it? Same location. If it reflects across the x-axis, it's going to flip upside down. But if I just rotate it on the y-axis, it's going to be the exact same shape that I had originally. Let's look at another one. This one is a linear function. It says describe the reflection of y equals negative x, then graph the function. So let's start with our parent function. We know that parent function is y equals x, right? So let's graph y equals x. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. It's going to be a line. Okay, we're going to use a dashed line, of course, to represent this. So that negative is going to reflect our graph some direction. Is this inside or outside of the function? Inside. Let me show you what it would look like if it was outside. It's the same, isn't it? When we talk about linear function, there really isn't an inside or outside of the function. You can pick either one, it doesn't matter. Okay, because you're going to go the same direction. So I'm going to reflect this across one of the axes. It doesn't really matter because it's going to be the same graph. If I reflect this across the x-axis, isn't that going to come down here? And this is going to go up here. So it's going to be this line. If I reflect it across the y-axis, isn't this going to go over here? And then this would come over here. It would still be the same shape, wouldn't it? Okay? So take each of your points and just reflect them across the axis. This time we'll draw a solid line. Again, for linear functions, there really isn't an inside or outside. I would take either reflects across the x or y axis here. Sorry. And that same thing goes for translations. There's really not an inside or outside of a linear function identity here. It's the same thing. I've got one more for you. This will be our last one. We're running out of time. I know that. I want to get through one more with you. In this last example, it says to describe the reflection y equals negative absolute value of x. Then describe the graph function. So let's start by graphing our parent function. You guys should be able to do this. Y equals the absolute value of x. You know this graph is going to be a V. In our transformation, what is that negative going to do? Is it going to reflect it across the x-axis or the y-axis? X-axis. And we know that because it's outside of our function, outside of the absolute value bars. It's going to reflect it across the x-axis. So please take all of your points and flip them down. Reflect those points down across the x-axis. We're not going to worry about dilations. When you get to college algebra, advanced algebra, you will definitely talk about dilations. On algebra 2, our goal is to make sure you know shifts, up, down, right, left, and reflections. So, page 112, that table, you guys need to get that in your mind. I can't use that on a test or quiz. You need to know if you're adding something or subtracting something in or outside of a function, what direction that's going to shift it. Also note where the negative is. Is it inside the function or outside? That will determine which way we're reflecting. Alright, today's assignment is out of the textbook. I have graph paper for you so you can do all of the work on here.